With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I am your teacher for this question, and the question is 0.5 gram mixture of K2Cr2O7 and KMnO4 was treated with excess of Ki in acidic medium. Iodine liberated required 150 cm³ of 0.1 normal solution of thiosulphate solution for titration. So find the percentage of K2Cr2O7 in the mixture. So in the question it is given that a mixture of K2Cr2O7 and KMnO4 is total 0.5 gram and is treated with excess of Ki in acidic medium. The iodine is liberated and further the iodine required 150 cm³ of 0.1 normal solution of thiosulphate solution for titration. So we have to calculate the percentage of K2Cr2O7 in the original mixture. So first we will see when K2Cr2O7 and KMnO4 react with Ki solution. So K2Cr2O7 plus KMnO4 plus Ki. So K2Cr2O7 solution means its dichromate ions will get converted to Cr3 positive and permanganate ion will be get reduced to Mn2 positive and the iodide ion in Ki will be oxidized to I2. So first we will see the N factor for all the compounds. Here the oxidation state of chromium we can calculate. The oxidation state of potassium is +1, so for 2 it will be +2. Let us say for chromium it is X, so for 2 chromium it will be 2X, and for 1 oxygen atom it is -2, so for 7 it will be -14. So this will give us 2X minus 12 equals to 0. That is 2X is equals to 12 and X is equal to 6. It means the oxidation state of chromium is here +6 and here it is +3. It means for 1 chromium atom the change in oxidation state is of 3 and for 2 it will be 6. It means N factor for K2Cr2O7 when it gets reduced to Cr3 positive is 6. Now we will see for manganese. In manganese KMnO4 the oxidation state of manganese is +7 and it is reduced to +2. It means the change in oxidation state is of 5. And here is 1 manganese atom, so the N factor for KMnO4 is 5. Now when iodide ion is in Ki, it is present in -1 oxidation state, and when it is oxidized to iodine it is oxidized to 0. It means the change in oxidation state is of 1, so the N factor for iodine or Ki we can say it is 1. So now when the mixture of K2Cr2O7 and KMnO4 is treated with excess of Ki, so their number of equivalents of this mixture will get equal to the number of the iodine solution, iodine liberated. So we can write equivalent of the iodine liberated will be equal to the equivalent of KMnO4 and equivalent of K2Cr2O7, and the number of equivalents are given by number of equivalents can be calculated by number of moles into N factor or valency factor, which is the total change in the oxidation state. So for iodine we can say the number of moles of iodine are not given, so we can calculate the number of moles of iodine from here and its N factor is 1. Now let us assume the number of moles of KMnO4 be X and K2Cr2O7 be Y. So the equivalents of KMnO4 would be the number of moles of KMnO4 into its valency factor, and number of moles of KMnO4 be equal to its given weight upon its valency factor. Sorry, we can assume the mass of KMnO4 be X grams and the let mass of or weight of the KMnO4 be X grams and the K2Cr2O7 be Y grams. So we can write here the number of moles as X upon given weight upon molecular weight of this. So this will be 158 into its valency factor, that is 5, plus the equivalence of K2Cr2O7, which is the given weight of the K2Cr2, that is y gram, and its molecular weight upon 294 into its valency factor, that is 6. So from here we get equation, that is number of moles of iodine liberated will be 5x by 158 plus 6y upon 294. Now this iodine solution which is liberated is again treated with the thiosulphate solution for titration, which requires 150 centimeter cube of 0.1 normal solution. So it means in the next step the moles of or the equivalents of iodine liberated will be equal to the thiosulphate solution. So we can say equivalents of iodine liberated will be equal to the equivalents of thiosulphate solution. The equivalents or the moles of iodine we can say are this we have calculated, that is 5x upon 158 plus 6y upon 294. This will be equal to the equivalents of thiosulphate. So equivalent of thiosulphate solution can be written as its concentration into volume, that is normality into volume, because normality is equal to the number of equivalents upon volume of solution in liters. So we have to calculate the number of equivalents. So we will multiply normality by volume. So the normality is given 0.1 normal and the volume is given 150 centimeter cube. So we can say this is 1 centimeter cube is equal to 1 ml. So this is an ml. So to convert this into liters, we will divide by 1000. So this will give us 5x upon 158 plus 6y upon 294 equals to 0.015. So we have this equation, and another equation is we have the total mixture is 0.5 gram. It means x plus y is equal to 5 gram, because we have supposed x is the mass of KMnO4 and y is the mass of K2Cr2O7. So this will be equals to 5. So when we put y is equals to 5 minus x in this equation 1, we will get the value of y, and the value of y calculated is 0.073 grams and x is 0.427 grams. It means KMnO4, the amount of KMnO4 is, or weight of KMnO4 is this 0.427 grams, and the amount of K2Cr2O7 is 0.073 grams. So we have to calculate the percentage of K2Cr2O7. So the percentage of K2Cr2O7 will be K2Cr2O7 will be 0.073 grams to the total gram, that is 5 gram into 100. So this will give us 14.6%. Similarly, we can calculate the percent of KMnO4 by is equal to 0.47 upon its total weight into 100. That will give us 85.4%. So percent KMnO4 will be 85.4%. So I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.